What you're looking at here is what was left after one of the strongest tornadoes ever recorded passed through a suburban American city. In less than an hour, entire neighborhood ceased to exist. Not burned, not buried, just simply erased. And despite how familiar the name Moore has become, much of what made this tornado so extreme was not obvious while it was happening. The destruction did not come without warning. A multi-day tornado outbreak was underway across the central United States, driven by a slow, unusually deep trough of low pressure sweeping east. This allowed specific atmospheric ingredients to come together over Oklahoma. Extreme instability, deep moisture, and wind strong enough allowed to support violent storms. But near the surface, the wind shear looked underwhelming. From a meteorologist's perspective, May 20th did not appear especially dangerous, just uncertain. The Storm Prediction Center issued only a 10% tornado outlook across central Oklahoma. That uncertainty mattered. Storms began forming along a dry line during the early afternoon. Most struggled. They were disorganized, messy, and failed to rotate, exactly what forecasters had expected. But beneath the visible chaos, a small pocket of rapidly accelerating air developed near the surface. It wasn't well sampled by radar, and forecasters didn't know it existed in real time. Southwest of Moore, one storm was shoved off its normal path by neighboring cells, forced into an unusual southeast motion. As that happened, rotation abruptly tightened. Early footage shows a weak, struggling tornado, lifting and reforming repeatedly, barely strong enough to knock over fences and snap small trees. Then, without any gradual transition, the vortex fully condensed. Within seconds, well-constructed homes were swept completely off their foundations. Grass and soil were torn from the ground in deep streaks, a process called ground scouring that is rarely documented outside the most violent tornadoes. What made this especially unsettling was how localized the damage was. Just a few hundred yards away, structures remained standing. As the tornado entered Moore, it expanded into a large wedge, approaching a mile wide. Vehicles were lofted and mangled beyond recognition. One lesser-known detail, multiple oil tanks weighing tens of thousands of pounds were carried more than a mile through the air. One was never recovered. Inside Briarwood Elementary, teachers filmed as roofs filled around them. The bathrooms, reinforced only by coincidence, saved every life inside. But minutes later at Plaza Towers Elementary, the tornado's core passed directly over third-grade classrooms. 7 children were killed almost instantly. Another rarely discussed behavior occurred near the tornado's end. Instead of lifting, the circulation slowed to under 10 miles per hour and looped back on itself, re-impacting areas it had already devastated. Just as suddenly as it intensified, the tornado narrowed, roped out, and vanished. In 39 minutes, the Moore tornado destroyed over 1,100 homes, 3 schools, and a major hospital. It was rated EF5, but even today, researchers still debate whether parts of the damage exceeded what the scale can adequately describe. What the cameras captured wasn't just destruction, it was a storm behaving in ways we still don't fully understand. Just days earlier, in the entry previously mentioned, an EF5 had devastated Moore, leaving the Oklahoma City metro in shock. But the atmosphere doesn't pause for recovery. As that system pushed out east, another would follow close behind. Forecast models showed a strong trough intensifying over central Oklahoma, with winds rushing from high to low pressure. Moisture from the Gulf flooded northward. Heat built at the surface, and strong winds aloft created deep wind shear. On paper, the ingredients for violent supercells were all there, but not every supercell becomes a disaster. By late afternoon on May 31st, storms began firing west of Oklahoma City. Storm chasers were already in position. Reno became the focal point, close enough to the risk, but far enough from the metro traffic. At 4:30 p.m., radar showed small blips forming along the dry line. Within minutes, they began merging, and one storm became dominant, tapping into the atmosphere more efficiently than others. At 6:01 p.m., the first tornado report came in, but pinpointing where it truly touched down is difficult. Instead of a classic funnel, dust rolled erratically beneath a massive wall cloud. Small funnels formed and vanished. Multiple subvortices appeared, separate tornadoes rotating around a common center. At times, there were twins, even quadruplets. The storm was moving southeast at about 20 miles per hour, or so it seemed. What few people realized in real time was that the tornado wasn't just moving, it was expanding. Later analysis showed the wind field was growing outward faster than any tornado ever documented. Within minutes, it reached an unprecedented 2.6 miles wide, making it the largest tornado in recorded history. The visible funnel accounted for only a fraction of the circulation. The most violent winds existed far outside anything that looked like a tornado. Mobile Doppler radar trucks captured something even more disturbing. Wind speeds approaching 300 miles per hour, the highest ever measured in a tornado. Inside the circulation, multiple intense rotations formed simultaneously, tugging the main vortex into unpredictable directions. At one point, the satellite vortex raced around the parent circulation at 170 miles per hour, the fastest forward speed ever recorded for a tornado. This erratic behavior proved deadly. Storm chasers pinpoint south and east of the tornado and assumed that it would move northeast, as tornadoes usually do. Instead, it surged east at over 50 miles per hour. Rain wrapped around the circulation, hiding it completely. To many, it appeared stationary, the most dangerous illusion of all. In the chaos, the Twist-X team, veteran storm chasers known for collecting life-saving tornado data, found themselves trapped. The last recorded words reflected sudden realization. I think we're in a bad spot. 90 seconds later, the tornado overtook them. Tim Samaras, his His son Paul and Carl Young were killed. It was the first time a tornado had ever killed professional storm chasers. As the tornado approached Interstate 40, panic spread across the Oklahoma City metro. Traffic jammed the highway. Entire families were caught in the open. And then, just as suddenly as it had grown, the circulation became chaotic and weakened. In seconds, the largest tornado ever recorded disappeared. 8 people were killed, none by collapsed buildings. That may be the most unsettling fact of all. The Reno tornado didn't leave behind classic EF5 destruction, which is why it was officially rated an EF3. But what cameras and radar captured forced scientists to confront a terrifying reality. Tornado strength, size, and danger don't always match the damage left behind. And sometimes, the most violent tornado on Earth is the one you never fully see coming. Two small Alabama towns, less than 20 miles apart, both will be hit by the same tornado at full strength. There would be no weakening, no break in the damage path, no second chance. This was the Hackleburg Phil Campbell tornado. The story of this monster began the day before, April 26, 2011. Forecasters at the Storm Prediction Center noticed a rare and dangerous setup across the southeast. Extreme wind shear would overlap highly unstable air, a combination known for producing long-track, violent tornadoes. A rare high risk was issued for Alabama and surrounding states. Overnight, storms swept through the region, knocking out power and communications across much of northern Alabama. By morning, the atmosphere recovered rapidly. Warm, moisture-rich air surged from the Gulf, while the leftover outflow boundary lingered, primed to trigger explosive storms. By early afternoon, on April 27th, storms erupted along the Mississippi-Alabama border. West of Hamilton, Alabama, a tornado formed. Within minutes, it became a violent wedge. The tornado raced northeast at nearly 52 miles per hour, growing wider and stronger as it moved. Homes were swept from their foundation. Cars were thrown hundreds of yards. Even storm shelters failed. Residents described the sound not as a roar, but a deep vibrating hum, like standing next to an enormous engine. What makes this tornado especially terrifying is that it never weakened. After devastating Hackleburg, it continued directly into Phil Campbell, striking a second town at the same violent strength. There was no recovery period, no structural fatigue, just uninterrupted destruction. In Phil Campbell, roads were scoured, asphalt was ripped from the ground, vehicles were lofted and shredded. Survivors were pulled from debris where entire streets had vanished. What was odd about this particular storm was the extreme pressure drop. Multiple survivors reported intense physical pain, ruptured eardrums, bleeding sinuses, and even cracked teeth, caused solely by the sudden pressure change. The tornado stayed on the ground for over 130 miles, remaining violent for an unusually long portion of its path. It crossed rivers, forests, highways, and towns before finally weakening near Harvest, Alabama. By the end, 71 people were dead, not because warnings were ignored, not because people failed to take shelter, but because this tornado didn't give either town a chance. The Hackleburg Phil Campbell tornado wasn't just powerful, it was relentless, and it remains one of the clearest examples of how little margin for survival exists when a violent tornado refuses to weaken. By late afternoon on May 22, 2011, Joplin, Missouri appeared to be experiencing another routine spring storm. Graduation ceremonies had just ended, families were gathering, restaurants, stores, and churches were still open. To most residents, the weather felt familiar, unsettled but not alarming. 2 days earlier, the Storm Prediction Center had identified conditions favorable for severe weather across the central United States. By the morning of May 22nd, Joplin sat inside a low but notable tornado probability zone. Not high enough to suggest catastrophe, but just high enough to be remembered later. Throughout the afternoon, isolated supercells developed across Kansas and Oklahoma, drifting northeast. Tornado watches were issued, but in southern Missouri, these alerts were common enough to fade into the background. Sirens sounded briefly, then stopped. Shortly after 5:30 p.m., a supercell southwest of Joplin began rapidly intensifying. Radar showed increasing rotation. A tornado warning was issued for the city. Minutes later, at approximately 5:34 p.m., a tornado touched down on Joplin's western edge, near Galena. What followed was not a typical tornado. Instead of a clearly visible funnel, the circulation became heavily rain-wrapped, almost immediately. From the ground, it appeared as a dark, advancing wall of wind and rain. There was no clear outline, no obvious shape. In many areas, visibility dropped to near zero. This made the storm especially dangerous. Many people never realized the tornado was present until it was already impacting their location. Within minutes of touching down, the tornado expanded rapidly into a massive wedge, eventually growing to over a mile wide. Wind speeds were later estimated to exceed 200 miles per hour, placing it firmly in the EF5 category. Entire neighborhoods were swept away from their foundations. Well-constructed homes were reduced to bare slabs. Vehicles were thrown hundreds of yards and mangled beyond recognition. One lesser-known detail is the tornado's forward speed. It moved quickly through the city, leaving little time to react, especially after warning sirens failed to remain consistent. Combined with the rain-wrapped structure, this drastically reduced survival windows. Radar analysis later revealed debris being lofted more than 20,000 feet into the atmosphere. Power flashes illuminated the storm as transformers exploded, briefly revealing the massive wedge hidden in inside the rain. These flashes were some of the only visual confirmations that a tornado was even present. Critical infrastructure laid directly in its path. Major hospitals sustained catastrophic damage while still occupied. Commercial corridors were flattened. Entire stretches of roadway were erased so completely that landmarks no longer existed, complicating emergency response. By the time the tornado had exited the eastern side of Joplin and began to weaken, over 1/4 of the city had been destroyed. The final numbers are difficult to even process. 158 people died, thousands of homes destroyed, and it left billions of dollars in damage. In the weeks following the disaster, an unusual secondary threat emerged. Several survivors developed a rare fungal infection caused by airborne soil debris, something almost never documented after tornadoes. It was a reminder of how violently the environment itself had been disrupted. Today, Joplin has rebuilt. Streets have names again, buildings stand where rubble once lay, but the storm remains a benchmark among meteorologists and emergency planners, a case study in how ordinary conditions can escalate into something far worse. The Joplin EF5 tornado is not remembered just for its strength, but for how it arrived quickly, moved quickly, and struck directly through a populated city. On May 27, 1997, two small towns in central Texas sat beneath a sky that looked harmless. No towering storms, no sense of urgency. It felt like a normal late May afternoon. Less than an hour later, one of the most violent tornadoes ever recorded would move directly through them. It wouldn't race across the landscape. It wouldn't roar past in seconds. Instead, it slowed down, stood upright, and appeared to walk through the community, leaving almost nothing behind. What happened in Jarrell, Texas would go on to redefine how meteorologists understand tornado intensity and survivability. This is the story of the Jarrell dead man walking tornado. In the days before the outbreak, forecasts had called for moderate severe weather risk. A few tornadoes were possible, but nothing about the setup appeared unusual. The morning of May 27th was calm. Skies were blue and there was little indication of danger. By midday, storms began forming northeast of Jarrell. One storm quickly became dominant near Waco, but instead of moving northeast, it drifted southwest, placing Jarrell directly in its path. Early tornadoes touched down near Moody, Texas. All were weak, all were short-lived. This offered false reassurance. By mid-afternoon, a thin, needle-like tornado descended just miles from Jarrell. Though narrow, its winds were already violent. As it weakened, many believed that the threat had passed. They were wrong. Less than a minute later, a much stronger tornado formed, rapidly evolving into a multi-vortex structure. Smaller funnels rotated around one central core, creating the appearance of legs in motion. Photographs captured it, a figure walking across the land. This phenomenon is known as the dead man walking tornado. Almost immediately, the tornado began scouring the ground. Up to 18 inches of soil were stripped away, exposing bedrock. Debris filled the circulation, creating a sandblasting effect of extreme intensity. As it approached Double Creek Estates, the tornado widened and slowed to walking speed, yet it did not weaken. This became its most lethal trait. Sirens had been sounding, but the subdivision had few storm shelters. The tornado stalled over homes, subjecting them to sustained EF5 winds minute after minute. Homes were not simply destroyed, they were pulverized. Concrete slabs were scoured clean. Vehicles were mangled beyond recognition. In the core of the damage path, no one above ground survived. Entire families were lost within seconds. Only 2 storm cellars saved lives. Outside of those storm shelters, survival was almost non-existent. When the first responders arrived, the area appeared erased, like a neighborhood that had never existed. Victims were identified using dental records. In total, 27 people were killed, 13 were children. Today, a memorial park stands where the homes once stood. The Jarrell tornado is remembered not just for its strength, but for how it slowed down, stayed violent, and walked through a community that never stood a chance.